Hello everyone, welcome to IP Math Solution. Today we'll be solving problems from review set 2A. So let's get started. Let A be the set of letters in the word Venn and B be the set of letters in the word diagram. So list the elements of A and B. So set A is going to be P, E, N, and set B is going to be D, I, A, G, R, and M. So we know when we have duplicacy, we write that element only once. So we have done this. Find the number of elements in A and the number of elements in B. So the number of elements in A is 3 and the number of elements in B is 1, 2, 3, 4, 5, 6. Find A intersection B and comment on your answer. So A intersection B is going to be, let's take a look. B is not present here, E is not present here, N is not present here. So A intersection B is going to be an empty set, which is denoted by this symbol. Since there is no common letter in set A and set B, therefore A intersection B is an empty set. Decide whether the statement is true or false. V is not an element of A. V is, from here we can see V is an element of A, so this statement is false. G is an element of B. G here is an element of B. This is what this statement says, so it is true. Number of elements in A union B is equal to the number of elements in A plus the number of elements in B. So we know that the number of elements in A union B, the formula is the number of elements in A plus the number of elements in B minus the number of elements in A intersection B. Now from here we know that number of elements in A intersection B, this part is 0. So we can say the number of elements in A union B is equal to the number of elements in A plus the number of elements in B. And this statement here is true. Let's go to the next question. If U, that is the universal set, is a set of multiples of 6 less than 70 and A is a set containing 6, 6 square and 66, find A complement. First, we need to write the elements of the universal set. Multiples of 6 less than 70. So 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, and that's all. Now set A is 6, 6 square, 66, or we can write it as 6, 36, 66. Now we know this element is present here, this element is present here, and this element is present here. So A prime or A complement will be everything from U that is not a part of A. So we'll start from 12. 24, 30, 42, 48, 54 and 60. And this is our answer. Let's go to the next question. Decide whether each statement is true or false. So first, let's write what this n is. N is a set of natural numbers, and that is 0, 1, 2, 3, 4, 5, 6 till infinity. What is q? Q is a set of rational numbers. And what are rational numbers? They are either of this form, that is p divided by q, or rather, let's not write p and q. A divided by b, where a is an integer, b is also an integer. Or a rational number can be of the form 1.02, 3.968, 1.0003. All those decimal numbers that terminate are rational numbers. And rational number is also of the form non-terminating but recurring. These numbers are non-terminating. That means this number will be like this form. So this number is non-terminating, but it is recurring. The digit 3 here is recurring till infinity. Therefore, these are rational numbers. Now, the question says, the set of natural numbers is a proper subset of rational numbers. So these are natural numbers and these are rational numbers. So can we write natural numbers in this form or this form or this form? Yes, we can write all the natural numbers in this form. This form. All the natural numbers can take this form. Therefore, the set of natural numbers is a proper subset of rational numbers. Yes, this statement is true. Now, is 0 an element of positive integers? So what are positive integers? First, we write positive integers. Positive integers are like 1, 2, 3, 4, 5, 6 until infinity. So is 0 a part of this? No, that means this statement is false. Is 0 an element of rational numbers? Now we know rational numbers are of this form. So 0 divided by 1 is also of this form. 0 divided by 1 is equal to 0, and it is a rational number. So yes, we can say 0 is an element of rational numbers. This is true. Part D says R, that is real numbers. This R means real numbers. Is R a subset of rational numbers? Is real numbers a subset of rational numbers? No, or rather that is opposite. Rational numbers are the subset of real numbers. So this statement is false. Let's go to the next question. Represent on a number line. X is an element of natural numbers such that x is less than or equal to 6. So it will start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So we know this line represents the set of natural numbers. And we know x is less than or equal to 6. So X is going to be this. This is X. Part B says X is an element of real numbers such that X is greater than or equal to -3 and less than 2. Now this X is between -3 and 2. So -3 is here. So we can say -3 is here, and this circle has to be filled because -3 is included. 2, +2. +2 is here. This circle needs to be empty because +2 is not included, and this line is our X. Now see, X is a set of real numbers such that X is between 0 and 4, both included. This union X is a set of real numbers such that X is greater than or equal to 10. This line is a set of real numbers. Now says X is a set of real numbers such that X is between 0 and 4. 0 and 4 both included. So this is going to be 0, 0 is included, and 4 is also included. So this line and union X greater than or equal to 10. So this is going to be all numbers above 10. So this is our X. First part is this, and then union this part. Let's go to the next question. Let U, that is the universal set, be a set of positive integers such that those integers are less than or equal to 30. So U is a set of positive integers that is going to start from 1, 2, 3, 4, 5, 6, and so on till 28, 29, and 30. P is a set containing factors of 24. Therefore, 1, 2, 3, 4, 6, 8, 12, and 24. Q is a set containing the factors of 30. 1, 2, 3, 5, 6, 10, 15, and 30. The question says list the elements of P, that is A part 1, Q, this is A part 2, C is P intersection Q. So P intersection Q is going to be this, 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 and that's it. P intersection Q is going to be a set containing 1, 2, 3, and 6. Part 4 says P union Q. P union Q. So it is going to be every element of P and Q written only once. That is going to be 1, 2, 3, 4, 6, 6, 8, 12, 24, 5, 10, 15, and 30. Part B says show that the number of elements in P union Q is equal to the number of elements in P plus the number of elements in Q minus the number of elements in P intersection Q. Now elements in P union Q is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The number of elements in P is going to be 1, 2, 3, 4, 5, 6, 7, and 8. The number of elements in Q is going to be 1, 2, 3, 4, 5, 6, 7, and 8. The number of elements in P intersection Q is going to be 1, 2, 3, and 4. So, the number of elements in P union Q, writing this equation, is equal to the number of elements in P plus the number of elements in Q plus minus the number of elements in P intersection Q. So can we write this is 12, this is 8 plus 8 minus 4. Now this is 12 as well. Hence the left hand side is equal to the right hand side as shown. Let's go to the next question. Let U, that is the universal set, be a set of letters in the English alphabet. So this is going to be A, B, C, D, E, F, G, H, and so on till X, Y, and Z. Set A is the letters in the word Springbok. That is going to be S, P, R, I, N, G, B, O, and K. Set B contains the letters W, A, T, E, R, B, U, C, and K. Now the question is asking, describe each of these sets and list their elements. So A union B. A union B is going to be all the letters from both the sets written only once. So let's first mark the letters that are common in both. So S is not present here, P is not present here, R, yes, R is present here, I not present, N not present, G not present, B, yes, B is present, O is not present here, K is present. So A union B is going to be S, P, R, I, N, G, B, O, K, W, A, T, E, U, and C. A intersection B is going to be a set containing R, B, and K. A intersection B prime, or A but not B. A but not B. So that is going to be A but not B. So what are the letters that are present in B? This one, and this one. So everything in A apart from these three letters. So that will be A, S, P, I, N, G, and O. Part B says, show U, A, and B on a Venn diagram. A intersection B, that is the intersection part. That's what we write in the very first place. So R, B, and K is going to come here. This set is A, this set is B. Now from A, what are the letters that we have not written yet? S, P, I, N, G, and O. From B, what are the letters that we have not written yet? Are W, A, T, E, U, and C. So what are the letters that are still remaining from the universal set? So let's write. We have already done A, B, C. D has not yet come, so D is going to come here. E, F, G, H, I, J, K, L, M, N is here. O, P, Q, R, S, T, U, V, W, X, Y, and Z. So they all should add up to 26. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. So this is our answer. Let's go to the next question. On a separate Venn diagram, like the alongside shade n complement. So n complement is going to be everything outside n. So this is going to be this part. M intersection n. M intersection n is going to be this part, this region. M but not n. M but not n is going to be this region. Let's go to the next question. Write an expression for the region shaded in blue. So the blue part is outside circle C. So can we say blue region can be represented by C prime or C complement? And the red region is A intersection B along with A intersection C. So this region is A intersection B and this region is A intersection C. So we can say the red region is A intersection B union A intersection C. And this is our answer. U is a set of all positive integers such that those integers are less than or equal to 10. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and 10. So this is U. P is going to be odd numbers less than 10. So odd numbers is 1, 3, 5, 7, and 9. Q is even numbers less than 11. Even numbers less than 11 are 2, 4, 6, 8, and 10. Now the question says list the sets P and Q. So we have already done it. What can be said about sets P and Q? So by just looking at set P and set Q, we can say set P has all the odd numbers and set Q has all the even numbers. And if we combine these two sets, the set will form is the universal set. So the first thing we can say about P and Q is that P union Q is equal to the universal set, and also P is equal to Q complement, because all the elements of the universal set that are not present in P are present in Q, And same goes the other way. All the elements of the universal set that are present in Q are not present in P. Therefore, we can say P is equal to Q complement, or P complement is equal to Q. C illustrates sets P and Q on a Venn diagram. So this is P and this is Q. P contains 1, 3, 5, 7 and 9. Q contains 2, 4, 6, 8 and 10. They don't overlap, they don't intersect. So this is our answer. Let's go to the next question. The racket sports offered at a local club are tennis, badminton and squash. The Venn diagram shows the number of members involved in these activities. All the members played at least one racket sport. So part A says write down the number of members in the club. So the number of members in the club is going to be number of members in the club is going to be, now we know all the members play at least one racket sport. So we know that all the members will fall under these circles. That is going to be 15 plus 7 plus 8 plus 5 plus 4 plus 6 plus 11. So this number is going to be 15 plus 7 plus 8 plus 5 plus 4 plus 6 plus 11 is going to be 56. Part B says write down the number of members who only play badminton. So the answer is 8. Do not play tennis. Do not play tennis is going to be 8 plus 6 plus 11. That is going to be 25. And part 3 says play both tennis and squash but not badminton. So play both tennis and squash but not badminton. So playing tennis and squash is this region but not badminton. So this part will be out. So the answer is 5 only. Part C says copy the Venn diagram above and shade the region that represents S intersection T union B. So T union B is going to be this part, this region. And intersection with S is going to be only this region. So if we shade this region, this is going to be this region. So this is part C. Now let's move on to the part D. Write down the number of members in SE intersection T union B whole prime. So T union B complement is going to be T union B is this region. T union B is this region, and its complement is going to be only this region, this 11 part. 11 and in intersection with S. So this region and in intersection with this region is going to be only 11. So S union, so S intersection T union B complement, it is going to be 11 only. Let's go to the next question. A school has 564 students. During term 1, 229 of them were absent for at least one day due to sickness, and 111 students missed some school because of family holidays. 296 students attended every day of term 1. This is for sickness, this is for family holidays. This is the reason. Reason is sickness, reason is family holidays. We know 296 students attended every day of term 1. So 296 is going to come here. We know there are a total of 564 students. So we can say the number of elements in A union B is equal to the number of elements in the universal set minus the number of elements in A union B complement. Therefore, this number we do not know, and this number is 564, and this number is this one, 296. So we can say the number of elements in A union B is 564 minus 296. This is 268. And we also know the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection B. This is 268. This is 229. This is 111 minus the number of elements in A intersection B. Here this sickness is A and family holidays is B. So we can say the number of elements in A intersection B is 229 plus 111 minus 268. That is 72. So this region, intersection region, has 72 students. And we know part A has 229. So 229 minus 72, we have 157 students here. And 111 minus 72, we have 39 students here. Now the question says display this information on a Venn diagram. So we have done it. This is part A. Find how many students missed school for both illness and holidays. Illness and holidays both is 72. Were away for holidays but not sickness. Holidays but not sickness. So that is 39. Were absent during term 1 for any reason. So that is going to be A union B. A union B is 268. Let's go to the next question. The main courses at a restaurant all contain rice or onion. Of the 23 choices, 17 contain onion and 14 contain rice. So we know there are a total of 23 choices. So the number of elements in the universal set is 23. And we know out of these 23, all contain either rice or onion or both. So there is no dish that does not contain rice or onion. So this region is going to be 0. Now 23 is also equal to the number of elements in R union O. And we know the number of elements in R union O is going to be number of elements in R plus number of elements in O minus number of elements in R intersection O. That is going to be 23. This is 17. This is 14. So the number of elements in R intersection O is going to be 17 plus 14 minus 23. That will be 8. So this region here contains 8 dishes. We know there are 17 containing onion. So 17 contain onion, out of which 8 we have already written. So this is going to be 9. And 14 contain rice, out of which 8 we have already written. So this is going to be 6. How many dishes contain both rice and onion? So the answer is going to be 8. Let's go to the next question. 38 students were asked what life skills they had. 15 could swim, 12 could drive, and 23 could cook. The number of elements in the universal set is 38. The number of elements in swimming is 15. The number of elements in driving set is 12. The number of elements in cooking set is 23. 9 could cook and swim. So the number of elements in cooking and swimming is 9. 5 could swim and drive. So the number of elements in swimming and driving is 5. 6 could drive and cook. The number of elements in driving and cooking is 6. There was one student who could do all three. So the number of elements in swimming intersection, driving intersection, cooking is 1. So we start with the intersection part. This is 1, so this 1 is going to come here. Now C intersection S is this region. It has 9 elements, 1 is already written, therefore 8 is remaining. S intersection D is this region. It has 5 elements, 1 already written, so 4 is remaining. D intersection C is this region. It has 6 elements, out of which 1 is already written, so 5 is going to come here. Now S contains 15 elements, out of which 8 plus 4, 12 plus 1, 13 we have already written. Remaining 2 will come here. D has 12 elements, out of which 5 plus 4, 9, 9 plus 1, 10 we have already written, so 2 is going to come here. C has 23 elements, out of which 8 plus 1, that is 9, 9 plus 1, 5, that is 14 we have already written, so 9 is going to come here. Now we know there are 38 elements in the universal set, out of which we have already considered all these. So what is the sum of all these? 2 plus 4, 6, plus 2, 8, 8 plus 8, 16, 17, plus 5, 22, plus 9, 31. So we have already considered 31 out of 38. The remaining 7 is going to come here. Now the question is asking, find the number of students who could only cook. Only cook is 9. Could not do any of these things. That is 7 from here. Had exactly 2 of these life skills. So exactly 2 is going to be this number, and this number. That is going to be 8 plus 4 plus 5. 17 is the answer. That's all for this exercise. I'll see you in the next session.